Mary, you want to start?
We did 13 on 3, page 152.
Okay. So, my initial velocity, now, they use V naught. The little subscript there just means initial usually, but I'm just going to make it X. So V1 is X, okay? I have a mass of 6 kg. A force of 36 newtons being applied. My V2 is double what that is. So how do I show double what X is? 2X. Okay? And it covers a distance of 10 meters. Alright? Okay, so I've got V2, I've got D, and I've got V1. And obviously I need to find my X's, right? But if let's say hypothetically I had values for all of these. What's the other piece of information that I always get from that bit of information right there? Acceleration. So how do I get my acceleration? Okay, so that gives me 6 meters per second squared. Now let's look at the information that I have here. I have V1, I have V2, I have D, and now I have A. So which equation deals with all of those? There's only one equation that doesn't deal with time. Which one is it?
V2 squared equals V1 squared plus 2AC.
Okay. So now let's just fill in the information that I have here. Alright, let's have a look. So, the catch in the question is, I have to square this whole thing right here. So that's going to end up being 4x squared. You follow?
Yep.
Alright. Then I have x squared here plus 120. So now just get your x's to one side. Isolate your x's, square root your x, and then you're done. Okay? So the question becomes more difficult because of this and this. But realistically, if I write out my information like this, because it's just force, mass, and acceleration, I get my acceleration, I can then use one of those 5 equations that I've used before. Okay? Alright. Next. Who else had questions? Samantha? Which one?
12.
Okay. Question 12. You're driving your car. You see a deer on the road. The deer is a certain distance from you. You need to hit the brakes before you hit that deer. So I need to find out how far is it that I'm going to travel at the moment I see the deer to the moment I stop. I need to know how far I travel. Now, I've got cruise control set on my car. Therefore, the reaction time it takes for me to see the deer and hit my brakes, I'm going to be going at a constant speed. So, in stage 1, I need to find out what my distance is that I traveled before I hit the brake. My time of reaction is 0.6 seconds. And my velocity is 72 kilometers an hour, which is how many meters per second? 20. So now, I can find out how far I traveled before I hit the brake. Right?
Oh. Oh, actually,
Now I need to find out how far I travel as the car is slowing down to a stop. So V1 is 20 meters per second. V2 is 0 meters per second. I likely need to get my A, and where does my A come from? What else do they give you?
Use a four.
They give you what?
Force.
A force
And
of negative 8,000 newtons. Is it slowing you down? And what's the mass of the car? 1,000 kg. So again, this question we've done before. We did it in kinematics. Alright, now the test, it was a James Bond question. Okay? You have to use force and mass again, get your acceleration. Once you have acceleration, you use your equation, the same one as the last question, to get your distance. So you add your distances together and find out if you're done, if you're there within 40 meters.
Oh, I just found one of them. I only found stage 2.
Okay, so there's also a split second, 0.6 seconds, in which it takes you to hit the brake. So you also have a little bit more distance traveled. Okay? Again, yeah, no problem. Again, this is a question you're going to see again. You will for sure see that question again. You've seen it once already in the kinematics unit, you're going to see it again on a test in this unit as well. Alright? Other questions? Elsie?
20. I'm just confused.
Which one?
20 on the next
53?
page.
A boy with a mass of 30 kg pulls a cart with a mass of 100 kg towards himself by a rope. Okay, so let's just kind of draw ourselves a picture. So this is 100 kg, right? The boy is right here. How much does he weigh? What's his mass?
30.
30 kg, I shouldn't use that word weigh, his mass. 30 kg. With what force does he have to pull on the rope to accelerate the cart at 2 meters per second squared? So my acceleration is 2 meters per second squared. You got your mass.
Oh,
Okay.
do you add the two?
Is he pulling himself?
No. Pulling that card or whatever.
Okay. And then once you've got that force, then you use the force here to get his acceleration. Okay?
Yeah, that makes sense.
All right. Any other questions off of?
41B, it says how strong must the tow rope between the ladders be? Do you want to find like kilograms of tensile strength or newtons?
Newtons.
Okay.
Well, you've got a plane
Yeah.
pulling the first glider, pulling the second glider, right?
Yeah.
They're all accelerating at the same. Okay? They want you to find that force right there,
So like, if
which is
you
only using,
accelerate-
you're only using the mass of the second glider then.
Right. So then you have an acceleration of 2.5 meters per second and a force of 800 kilograms, but then it's
So
still
a mass of 800 kilograms.
mass of 800 kilograms, you times it 2, but you get 2,000 newtons. So the slower you get, the faster you get 4,000 newtons. And that's the first glider is actually the second one. Second. I might have got those two mixed up. I think it's
Good.
yeah.
Alright. Anything else on that? I'm feeling like you're getting close to the end of that page, so you should be starting in on the worksheets.
Number 10 on page 151.
D1, Morgan.
400.
What's your V2?
100.
Alright. Morgan, what do I need in order to get my force?
Acceleration of the mass. The mass is 8 grams.
There's your mass.
The acceleration would be the average velocity over time.
Change of velocity over
Change
time.
of
yeah.
velocity. So 100 take away 400 would be negative 300. So I got negative 700.
You have a large number, yes.
Yeah, large
That's
number.
fine. That's right. And then times it by 8 over 1,000.
Negative 6,000.
Okay. Yep.
Yeah, I did something really, really stupid on this question.
You alright?
Yeah.
You got it right this time. Alright. Anybody else? Yeah.
On this new worksheet,
Yeah.
on page 3, number 5.
Okay. When you force acts on a body, 4 kg, just address, so my force applied is 20 newtons. Mass is 4 kg. Initially at rest is 0 meters per second. Time is 5 seconds. Displacement is 50 meters. Okay. I think I've covered everything, haven't I? Alright. So you need to get the A out of there. Right? And you know this. And then you need mass times acceleration.
Okay. Can you also do 4 then? Because 4 is the same question where it's looking for force
The
of
difference with
friction.
4 is, it's after it's released. So the only thing affecting it is your frictional force.
Okay.
So your net force and your frictional force equal each other, so when you find the A, it's equal to your frictional force.
Okay.
That make sense?
Yeah, that's what I was confused. Thank you.
Yeah, no problem.
So it would tell you, it tells you your frictional force or not?
In this one, you have to solve for it. And the other one, you've got no applied force, you've thrown the curling rock and let it go. So the only thing that's happening is frictional force is slowing it down. So your net force is equal to your force of friction, because there's no more applied on it.
Yeah.
Okay. Okay, you have the rest of the day to keep at that.